Hey, what's up, YouTube people? So, today we got our first no heat call of the year. For me, anyway. Maybe not for you, but for me. So, a little Lennox unit here. One of my guys found that it wasn't heating on a preventative maintenance call. So, we're going to open it up and see what's wrong. As you can tell, I took the door off, put it over here. It's really windy out. And what happens with these is they just bounce around. The way this hinge is laid out, it just bounces around and gets beat up and bent. And as you can tell, this one's been beat up and bent for a long, long time. So before I do anything, take the door off, we'll set it over there. Then we'll come back over here and put this thing in test mode. One of the things I immediately notice is terminals on that contactor look like they've been a little warm at some point in time. Alright, so I'm going to hit this shift dip switch. Unit test. C1 comes up on the little screen up there. Then we're going to hit this once, twice. H1, I'm going to go H10, then I hold it down until I see a little tiny decimal point right there, and then our heat should be engaged. Oh yeah. Inducer's running. No sparking. There we go, we got a spark. And we have full ignition, which is odd. Let's take this out of test mode. Put this back here, shift back over here. And we should be in normal operation right now. Now, I'm going to turn it off and just sort of visually inspect everything. I can figure out how to work these doors. So I'm kind of curious to know why I'm here on a no heat call that was found on a PM. Belt's nice and good. Slightly out of alignment, but not terrible. Not terrible. I know it's probably hard to see at the proper angle, but we're maybe a quarter inch this way. Not terrible, but nothing obvious over here. We'll check the heat exchanger on the other side in a second. Looks like the ignition module's been replaced at some point. Let's open up this cover here. Let's see if the contact points in that contactor are heavily pitted. That is a compressor contactor, so it shouldn't really affect anything to do with the heat. So again, that goes back to, why am I here? Am I here because there was actually an issue, possibly a intermittent no heating issue? Or am I here because the previous technician who did the preventative maintenance maybe didn't know how to initiate the test cycle? Who knows? But we're going to check everything out as much as we possibly can. Contact points look good. I almost wonder, so those contact points look really, really good. I'll bet you this contactor was just replaced sometime anyway, in the last, probably over the summertime. The wires are nice and tight, so that's not it. Well, let's go around and check our heat exchanger. How about that? And then we'll fire it up one more time just to see if maybe we can catch it intermittently firing. All right, heat exchanger. It's not terrible. It's also not the healthiest looking heat exchanger I've seen. I did go through all these rust spots with my screwdriver and scraped them all. It's just surface rust right now. Probably next season we'll probably have one of these little seams on the side or something like that will start to open up. But she's good. She's good today. She's good this year anyway. Alright guys, so I'm just going through kind of checking some of the wiring connections. And this little pressure switch connection right here, it's pretty corroded. Not real excited about that. It's not terrible. I mean, it's still going to make some sort of connection in there, but I just don't like it. Let me come down here. This, if I can get in there and show you. Right there. Our sparker wire is somewhat melted. Now that could probably cause intermittent issues. It may or may not spark every single time. Also, looks like somebody forgot to put some screws back. That's not cool. Hey, look at that. So I just touched it and it came off. So yeah, it's bad. So we're gonna get a new sparker wire, a new sparker, flame rod, and I'm also gonna quote that pressure switch just because I don't like the connections. So that's what we're gonna do. What do you guys think? Think it's a good idea? I have sort of what you might call like an always list, right? And I'm sure it varies from company to company and technician to technician. But for example, if I'm going to replace this wire here, normally if everything on this unit was the same age, I would replace just about everything. I would do my spark wire, my spark igniter, my flame sensor, my pressure switch, my rollout switch, and I would do an ignition module. But the ignition module is fairly new, so I'm just going to do the rest of it. But the way I look at it is there's no point in replacing just this wire, obviously, and leaving the 10-year-old spark igniter in there. And there's no point in doing the wire and the spark igniter and not doing the flame sensor, which is rusted out as well. Not terrible, but it is rusty. Well, there's no point in doing half of the components that make this thing heat. There's just no point. In the middle of winter, I don't want to come back and replace this flame sensor after I've replaced the spark igniter months ago, or replace a pressure switch after I replaced an igniter and a flame sensor. Makes no sense. So this is where I've kind of started to develop these always things, and I'm sure you guys do it. For example, you know, if you do a compressor, you always do the contactor, and depending on the layout of the machine, I almost always do condensing motors too. I don't install brand new compressors with old, aging, slow-moving condensing motors. It makes no sense. For an extra $200-300, if I can ensure that the brand new compressor is going to last longer with a brand new condensing motor, I'll do it. Since I'm on a ranting path, another thing I'm going to point out to you guys, turn these knobs the right way when you're done. That one's not quite right there. There we go. Make them nice and pretty, alright? Drives me crazy. See, look at this. That one, this one. It's not that much harder to do. Turn them all the way. there's a little groove in there that's going to keep it from, you know, slowly vibrating. This is the open position. Turn it this way, yeah, it's kind of closed. Probably won't come open, but you never know. Turn it this way, you'll feel a nice, gentle little click. All right, that's all for today, guys. I'm gonna quote some parts out. As soon as I get approval, I'll bring it back. We'll install these little parts, and we'll see what happens. All right, take it easy, guys. And we are back. As you can tell, got all new parts. My igniter, flame sensor, pressure switch, new rollout switch, and an ignition cable. So, let's get started. Out with the old, in with the new. Catch our wire. Good. Now let's do our pressure switch. And you'll notice this pressure switch is a little bit different. It should function exactly the same. Alright guys, having a little bit of trouble with this igniter, this spark electrode. Couldn't easily just fish it out of there like I was hoping without breaking it. So what I'm going to do real quick is right along here, you see all these four little bolts that hold this, I don't know, burner assembly in place, or these burners in place. I'm going to take those up, and then hopefully this burner just kind of pops right out, and then I can just slide this igniter out real quick and fast like. Alright guys, here's some footage of a screw coming out. Alright, slide that out of the way. Yeah, much easier. Here's our new one. Spark, and we got fire. If you guys can see that at all, temperature, it's up over 100, so we are good to go. Alright guys, simple little repair there. Hope you got something out of it. I did. Fun hanging out with you guys. We'll see you on the next one, alright?